Hi everyone, hope you all are good. So, we're going to start with grade 10 maths. So, we are following the book that is Nelson grade 10. So, we are already working on the chapter that is chapter 3 from the book, and the chapter name is Graphs of Quadratic. We're working on chapter 3, Graphs of Quadratics. So, we are going to continue the same chapter, and the topic we're going to start with is quadratic models using factored form. The lesson name is Quadratic Models using Factored Form. Please make sure you have your notebook and pencil so that you can note down important points on your notebook. Got it? Also, you can note down the questions I'm doing on the board. They are very helpful for you when you're doing the rest of the practice questions. Got it? Okay. So let's start with the topic that is quadratic models using factored form. So it is 3.5 on the book and the page is 100, page 169. You can find it on book page 169. Okay, let's cover the curve of a good fit. A curve that approximates or it's close to the distribution of points in a scattered plot is the curve of good fit. Got it? Then we had quadratic relation, a process that fits the second degree relation y equals ax square plus bx plus 6 to the data is known as quadratic regression. Curve of best fit. The curve that best describes the distribution of points in a scattered plot, usually found using a process called regression. Got it? The best fit is when you are working on the scattered plots, and the curve that describes the point distribution of points, got it, is known as the curve of best fit. Okay, then you have solved examples. We're going to start with the practice because you can do the solved example. So I'm going to start with practice questions. Okay, key idea. If a curve of good fit data with a parabolic pattern passes through the horizontal axis, then the factored form of the quadratic relation can be used to determine an algebraic model of the relationship. That means if the good curve of good fit is passing through the horizontal axis, that means on the x-axis, then we can find the factored form of the quadratic relation equation. Got it? Okay, the estimated or actual x-intercepts or zeros of a curve of good fit represents the values of r and s in the factored form of the quadratic relation. Because the curve of best fit is crossing through the x-axis, that means they has the zeros. So you can use these zeros to form the um, factored form of quadratic relation. Got it? The value of a can be determined algebraically by substituting the coordinates of a point other than a zero that lies or close to the curve of good fit into the equation and then solving for a. Okay, you got the equation from zeros. Now you have to find the value of a. So you can put another point other than zeros. Got it? And you can find the value of a. The value of a can be determined graphically by estimating the value of a and graphing the resulting parabola with graphing technology. By observing the graph, you can adjust your estimate of a and graph again until the parabola passes through or close to a large number of points in the scattered plot. Got it? Graphing technology can be used to determine an algebraic model for the curve of best fit. You can use quadratic regression when the data has a parabolic pattern. So that is basically the sum of the the summary of the lesson. So we can do the practice questions, then you'll get all these points. Got it? Okay, prac- let's start with the very first question. A parabola passes through the points. You are given with the points negative 4, 10, negative 3, 0, negative 2, negative 6, negative 1, negative 8, 0, negative 6, 1, 0, and 2, 10. Determine the equation of the parabola in factored form. Express your equation in standard form. Use a graphing calculator and quadratic regression to verify the accuracy of the equation you determined. Got it? So let's start with question number 4. Let me note down the points on the notebook, on the board. The points are negative 4, 10, negative 4, 10. Then we have, where is the uh, negative 3, 0, negative 3, negative 3, 0, negative 2, negative 6. Then we have negative 1, negative 8, 0, negative 6, 1, 0, and then 2, 10. Okay, and then we have to find, then we have to determine an equation for the parabola in factored form. Express your equation in standard form. Then use a graphing calculator and quadratic regression to verify the accuracy of the equation you determined. Got it? Okay, so let's start with the first part, determine an equation of parabola in factored form. Okay, so for the uh, equation in factored form, we'll have to look for the zeros. So here we have two of the zeros, negative 3, 0 and negative 3, 0 and 1, 0. Yes, we have negative 3, 0 and 1, 0. Use these zeros to find the equation. X equals negative 3. From this point, we have x equals negative 3, y is 0. And for this one, we have x equals 1. So we can write down the equation in standard form, that is y equals a times x minus 1 and x plus 3. That is the equation of the parabola in factored form. Got it? Now we have to find the value of a. You can use any other point other than these 2 points because they are the zeros of the equation. You can put any of the 2 points in the equation and you can find the value of a. Got it? So I'm going to use 0 and negative 6. Got it? This point to find the value of a. Y is negative 6. So let's just put the point negative 6. A x is 0 minus 1 and 0 plus 3. So it would be negative 6. 0 minus 1 is minus 1 and 3 plus 0 is 3. Negative 6 equals negative 3a. Then a equals 6 over 3. A equals 2. Got it? Now the equation is y equals 2 times x minus 1 and x plus 3. That is the equation that we have to find in part A. Got it? Okay, part B, express your equation. Okay, we have to express the equation in standard form. So for standard form, we have to expand the equation. Just multiply 2, multiply x minus 1 to x plus 3. So x times x is x square, x times 3 is 3x. Now multiply the negative 1. Negative 1 times x is negative 1x. Negative 1 times 3 is negative 3. So it would be 2x square. 3 minus 1 is 2x minus 3. Just multiply 2 to the numbers. They are 2x square plus 4x and minus 6. Got it? That is the equation y equals 2x square plus 4x minus 6. Okay, now you can use the graphing calculator and quadratic regression to verify the accuracy of the equation. Got it? So you can use any graphing tool. They can be Desmos or anything that you used in your class, your teacher used in your classroom. Got it? So this is the value of a and this is the equation in the standard form. Got it? If you have any question, you can use the live chat option. Write the question in the chat box. I'll explain the question. I'll explain your question. Got it? Okay, let's just do another example. Okay, now we have so many questions. Let me see from which question. Okay, let's start with question number 9. Okay, for a school experiment, Nicola recorded the height of a model rocket during its flight. The motion detector stopped working. However, during her experiment, the following data were collected before the malfunction. The height time relation is quadratic. Determine an equation for the height time relation. B. Use the equation you determined for part A. Estimate the height of the rocket at 3.8 seconds. C. Determine the maximum height of the rocket. When did the rocket reach its maximum height? Let's start with question number 9. Let me copy and paste the question on board. So most of the questions are same. You have to do the same things. The question is 2. Okay. So for a school experiment, okay, the height time relation is quadratic. Determine an equation. Okay. We are given the table. The values on the table are mm, 0 to 119.5. Okay, let me plot the points on the graph, on the graphic tool. Desmos. I'm going to use you can use any other graphing tutorial you are using in your classroom. Got it? I'm going to use the Desmos. Okay, let's start with the O0 to 119.5. Then you have 327, 327. Then you have, no, it's 327. Okay, then you have 327, and the next one is 227, 320. 227, 324.5. 227 and 324.5, and then 412. 4 and 12. Okay, so these are the points. These are the all 4 points. Got it? So you have to use quadratic regression to determine an equation. Let me see how to use quadratic regression. Quadratic regression calculator. Use quadratic regression earlier. That is just the first time I'm going to use the quadratic regression, because in the book you're told to use quadratic regression calculator. So let's just write the values here and just use quadratic regression. Okay, you have 0, 2, then you have 1 and 19.5, then you have 2 and 27, then you have 3 and 24, 3 and 24.5, and then you have 4 and 12, and the rest of them are 0. Okay, let's see what happened. Okay. Okay, yes, this is the graph for the this is the best fit graph actually. You can use the graphing calculator and you can use the graph and the best fit graph of the equation, but you have to find the equation using graphing regression. Mm, okay, yes, we have the values of A, B, and C. C. Look at here, the value of A is B 24 and C has the value -2. -5. Okay, so basically the value you get from the equation is the values are A equals -5, B equals 22.5, and C equals 2. So the equation is y equals -5x square plus 22.5x and plus 2. Got it? This is the value you got from the quadratic regression. Got it? Now for the B part, the height time relationship. B part, use the equation you determined for part A to estimate the rocket height of the rocket at 3.8 seconds. So basically you have to substitute x equals 3.8. Just substitute x equals 3.8 in the equation. Y equals -5 times 3.8 square plus 22.5 times 3.8 and plus 2. So it would be 3.8 square times 5 is negative 72.2 and plus it would be 85.5 and plus 2. So when you add them, it would be 15.3. That means when the height is 15.3. Got it? Determine the maximum height of the rocket when the rocket reaches its maximum height. Okay, again for the maximum height, you have to use the calculator. Got it? Okay. Okay, now let's just do question number 11. Examine this square dot pattern. Diagram 1, 2, 3. How many dots are in 20th diagram? Justify your answer. Okay, in the one you have 2, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Okay, so let's start with um, in diagram 1, you have two dots. Just look at the one side. You have two dots. For the second, they are increasing 1, 2, 3, 4. And for the third, they are increasing by again 2, 1, 2, 3, 4, 5, 6. Got it? So the pattern shows the side length of each square is 2n. For the one, it is, for the first one, it is, for the diagram 1, it is 2. For the diagram 2, it is 4. And for the diagram 3, it is 6. So that means they are increasing in 2n. Got it? You just put the total number of dots in any square pattern is equal to the number of dots on side squared. Got it? Just look at this one. Here you have 16. 1, 2, 3, 4. So 4 square is 16. Here you have 2. 2 square is 4. And here you have 6 square. They are 36. 1, 2, 3, 4, 5, 6. 1, 2. Yes, they are 36. Got it? So that means the number of dots is 2n. The side is 2n and the number of all the dots is 2n square. Got it? So we have to find how many dots are there in 20th diagram. So we need to see how many dots in 20th diagram. So for the 20th diagram, replace the n 20. It would be 2 times 20. That means they are 40. And when you have to calculate the total dots, so it would be a 40 square, or you can say 2n square. It would be 1600. That means in the 20th diagram, you have 1600 dots. Got it? Okay, so you can do rest of the questions by yourself. If you need more help with these questions, you can contact any tutor on Skype. They are available from Monday to Friday, 5 to 9. Got it? And all the questions are exactly the same, like we did two of the example. Got it? So try to solve them by your own. If more help with the topic, you can any tutor on the Skype. Got it? Okay, let's start with 3.6, that is exploring quadratics and graphs. Okay. Patterns in the table of values y equal to x can be used to determine the meanings of an. Here you are given, you have two of the graphs. One of them is for parabola and the other one is exponential graph. The one that is y equals to x, this is the exponential graph. So here is the difference between the parabola and the exponential graph. The graph is systematic about the y-axis. The graph is not systematic. The graph has an x-intercept of 0 and y-intercept of 0. The graph has no x-intercept and a y-intercept of 1. The y values decreases and then increase as x increases. The y value increase as x increases. As x increases in the positive direction, the y values increases. As x increases in the positive direction, the y value increases much faster than the y value for y equals x square. As x increases in the negative direction, the y value is increasing. As x increases, basically this is the difference between the two graphs. This is the exponential graph y equals 2x, and this is the parabolic graph y equals x squared. So these are the differences between these two graphs. Got it? Okay, let's start with the practice questions. Okay, let's start with question number 1. For part I, you made a conjecture about the value of the powers that with the exponent 0. You can confirm your conjecture using exponent rules. Okay, so you have to use the exponent rules and we have to see what is the values. Express 3 by 4 divided by 3 by 4 as a single power using the division rule for exponents. Okay. Mm, okay, let's start with 3 by 4 and 3 by 4 for the first part. We have to use the power rules too. So 3 by 4, both of them have the same bases. 3, this is the base. 3, 4, this is the base, and 4 is the exponent. Got it? So both of them have the same base. So when the bases are same, you can subtract the, because it is dividing, you, that means you have to subtract the exponents. So that means 4 subtract 4 is 0. Got it? Okay, now let's check for the B part. Rewrite the numerator and denominator of the expression 3 4 divided by 3 4 in factored form. Simplify where possible. What is the value of this expression? Got it? So we have to simplify them. 3 exponent 4 and 3 exponent 4. Factored form is 3 times 3 times 3 times 3 divided by 3 times 3 times 3 times 3. So it would be, they can cancel out each other and it would be 1. Got it? Okay, then for the C part, based on your results from part A and B, what can you conclude? Basically, the one thing you have to conclude is the 3 exponent 0, anything that has the exponent 0 equals 1. Got it? So any non-zero base that is raised, non-zero base raised to the exponent 0 equals 1. Got it? Here the base is non-zero, just the exponent is 0. That means when you have any non-zero base has the exponent 0, it equals 1. Got it? Okay, then for the D part, repeat A to C using 5 exponent 3 and 5 exponent 3, and you have to follow the same steps for 5 exponent 3. Got it? Okay. For question number 2, for part I, okay, let's start with question number 3. Evaluate each power. Express your answer in rational form. 2 exponent negative 4, 2 exponent negative 4. The power is negative. You have to make the power positive. You can write it in the denominator. Now, like the power is positive. Got it? Because the 4 here you have 2, and when negative powers can be made positive by writing them in denominator of a fraction. Got it? So it would be 1 over 2 times 2 times 2 times 2. So it would be 1 over 60. Got it? Okay, the next one is 8 exponent 0. So we just did 8, any non-zero base that has the exponent 0 equals 1. Got it? The next one is 4 exponent negative 1. So 4 exponent negative 1 is, again, you can make the power positive by writing it in a denominator. So it would be 1 over 4. Got it? Then you have 5 exponent negative 2. It would be 1 divided by 5 exponent 2. And it would be then 1 over 5 over 5, 1 over 25. Got it? Evaluate each power, express your answer in a rational form. Negative 2 exponent negative 5. Negative 2 exponent negative 5. Okay, so you can also make the power positive by writing it in denominator, 1 over negative 2 and 5. Got it? So you have to multiply negative 2 5 times. So and any negative number has the power, even power can result in positive number. So it would be negative number. It would be 1 over 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and 16 times 2 is 32. It would be negative 1 over 32. Got it? Negative 4 exponent negative 2. First make the exponent positive by writing it in denominator, and then you have to calculate the 1 over negative 4 times 4. It would be negative 1 over 16. Got it? Okay, then you have negative 7 exponent 0. So any number that has the power 0, any non-zero base that has the power 0 equals 1. So it would be then negative 1. Got it? Negative 4 exponent negative 3, 3. So make the power positive by writing it in denominator. So it would be negative 4 exponent 3. So just multiply negative 4 3 times. It would be 4 times 4 is 16, and 16 times 4 is 64, and it is negative 1 over 64. Okay, move on to question number 5. 1 over 2 exponent 2. Just calculate the squares of numerators and denominators as well. We know that 1 times 1 is 1, and 2 times 2 is 4. It would be 1 over 4. Then the second one is 1 over 2 and negative 2. Okay, here the exponent is negative. So you have to take the reciprocal. It would be then 2, and the power is now positive. Got it? So it would be then 2 square is 4. Got it? Then the next one is 2 by 3 exponent negative 3. You can take the reciprocal of the fraction to make the positive power positive. It would be then 3 by 2, and power is now positive. Got it? Just calculate 3 cube over 2 cube. So 3 cube is 27, and 2 cube is 8. So it would be 27 over 8. Got it? Okay, the next one is 3 over 4, negative 3 over 4 and negative 2. Okay, just write this negative sign is outside the bracket, just write it as it is. Take the reciprocal of the fraction and make the power positive, 4 by 3 and now 2. Got it? Just calculate the squares, negative 4 times 4 and 3 times 3. So it would be negative 16 over 9. Got it? Okay, the next one is determine the value of n that makes the each statement true. The first one is 2 exponent n equals 1 by 8. 2 exponent n equals 1 by 8. Okay, we can write 8 as 2 times 2 times 2, isn't it? 2 times 2 is 4 and 4 times 2 is 8. So you can write 1 by 8 as 1. It would be 2n equals 1 over 2 times 2 times 2. 2n equals 1 over 2 exponent 3. You can shift the power in numerator by making it negative. 2 times negative 3. Got it? Now the bases are same. That means exponent is also equal. So n equals negative 3. Got it? The next one is 5n equals 1. 5, sorry, 5n is exponent, not like this. 5n equals 1. So we need know that we can write um, any non-base 0, any non-zero base 0 equals 1. Got it? So here you have 1, you can write it as 5 exponent 0. Got it? Now that means here you have n equals 0. Got it? The next one is negative 3n equals negative 1 over 9. Negative 3n equals negative 1 over 9. So both the negative signs cancel out each other. It would be then 1 over 3 square. So you can write as a negative power by shifting it to numerator. So it would be then, sorry, negative 2, because you shift that 3 from denominator to numerator. Then n equals negative 2. Got it? Okay, the next one is 4n equals 64. So you can write 64 as 4 times 4 times 4. So 4n equals 4 cube, and that means n equals 3. Got it? The next one is n exponent negative 3 equals 1 over 27. So shift that, we can write the 27 as 3 times 3 times 3s, 3 cube we can write it as. So when you shift that negative 3 to the numerator, it would be then 3 exponent negative 3. Now the exponents of both of them are equal. That means their basis is equal. So n equals 3. Got it? Okay. Question number 7. What do you think 5 exponent negative 2? Which do you think is greater? 5 exponent negative 2 or 10 exponent negative 2? Justify your answer. 5 exponent negative 2 and 10 and negative 2. Let's see. 5 exponent negative 2 and 10 exponent negative 2. Okay, when you can write them as 1 over 5 square and 1 over 10 square. Got it? And 1 over 5 square, 1 over 5 square is 25. 1 over 25 and 1 over 100. So 1 over 25 equals 0.04, but 1 over 100 equals 0.01. So which one is greater? That means 0.04 is greater than 0.01, isn't it? So 5 exponent negative 2 is greater than 10 exponent negative 2. Got it? Okay. What do you think? Negative 1 exponent negative 100 or negative 1 exponent negative 101? Which do you think is less? Justify your answer. Okay, one of them is negative 1 exponent 100 and negative 1 exponent negative 101. Both of them are negative. Okay, negative 1 exponent 100 is even exponent. Got it? So that means the answer must be positive. And negative 101 is an odd exponent and it always makes a negative 1. Got it? So that means 1 is greater than negative 1. So negative 1 exponent negative 100 is greater than negative 1 exponent negative 101. Got it? Okay, so you can complete the uh, questions by yourself later today. If you need more help with the questions, with any question, you can contact any tutor on the Skype. They are available from Monday to Friday, 5 to 9. Got it? So we have completed the chapter that is quadratics, graphs of quadratics from Nelson book. If you need more help with any of the topic, you can contact any tutor on the Skype. So that's all for today. See you in the next class. Bye.